am an engineer, so that means that with my colleagues, I get to invent and make things. I get to invent the way that we make materials, I get to make products, I get to make devices. And what I've learned over the course of the years of inventing and making things is that I want what I make to impact the world. But the world of production is changing very rapidly too. So as we'll discuss today, production is not about making one amazing thing once. So as cool as this 3D printed material is, that's not production. That's invention, that's innovation, that's what happens at the lab scale. But production, today's production paradigm, is making things faster, making things more customized, making things in a more distributed way, and as we'll see, making things that are much more digitally integrated than ever before. And this is itself producing a lot of challenges and a lot of opportunities. So let's take one example. This is my phone. This is my iPhone. I bought it in Boston, near where I work. Many of the people who designed this device, the electronics, the hardware, the materials, they were educated at MIT. But this device wasn't designed at MIT, it was designed in Cupertino, California. And in fact, right now, the largest employer of the mechanical engineers coming out of MIT go work at Apple to do just that. But as we know, my phone was designed in California, but it wasn't produced in California. It wasn't manufactured in California. Instead, it was manufactured here in Shenzhen, in southern China. And it was manufactured at such low cost, so quickly, such high quality, that I have owned that phone as well as other phones that I've since broken their screens. We can't live without this kind of device, but is this the production paradigm of the future, where we design it here and we make it there? So the answer turns out to be no. Several studies have shown that you need to actually be able to innovate, prototype, manufacture where you invent for companies to be successful in the long term. And so I'll show you just one study from MIT. Suzanne Berger and her colleagues did a study called Production in the Innovation Economy. And they looked at 150 production firms that came out of just one university, MIT, over 1 decade. So of those 150 companies, you see that there's a wide variety of production sectors that are affected, ranging from biopharma to robotics to semiconductors to medical devices. So we touch a lot of sectors with what we invent and then are able to spin off into production firms. But when you look at those companies and say, which of these a decade later are still operating, here's what you see in this graph. And there's two things that you see here. Red means the companies are closed, blue means they merged with another company, green means they're still operating. So the first thing you see is that even in an environment as rich as the Boston-Cambridge area, with a highly skilled workforce, venture capital investment, lots of manufacturing capabilities in that environment, not all companies make it. That's not a surprise. Some companies succeed, some companies fail. But if you look at the companies that succeeded, the ones that are still operating are the ones that had the manufacturing innovation ecosystem right around them. So not a state away, not a globe away, but down the street or a car's ride away, very close to the companies. So this is part of what we've learned is production in today's innovation economy. Why is that? Because those companies could prototype quickly, could fail quickly, could develop their supply chains quickly to build that first production cycle and then move on to the next idea and prototype that. So that very quick turnaround, that ability to fail quickly is a hallmark of those successful companies. So we've always needed this connection between innovation and product, right? Between our ideas in our heads and then our ability to make it with our hands. And we've needed that manufacturing ecosystem. But what's special about those manufacturing ecosystems is now changing. Part of it is the proximity between the small and medium companies and the large companies, the physical proximity. Part of it is that you don't only just need more hands, different kinds of hands, highly skilled hands, but you need to figure out how those hands can work with robotic hands and this human-machine interface that is part of more automated production today. That requires a new skill set. But it's that transition that we're all making and that companies are, some struggling and some excelling to make, that allows us to get from a steel-bodied car with highly automated mass production to a 3D printed car in my lifetime, right, in a single lifetime. And so let's talk about 3D printing as an example. This is also called additive manufacturing, and this is thought of as a new manufacturing capability, an advanced manufacturing technology. But it's not new. In fact, most of the people who invented this manufacturing technology and the machines they built are retired. This has been around for decades. But when it first came out, when we were first developing this in the basement of university labs where the 3D printers took up a room of this size, there were a lot of basic science questions, a lot of R&D to de-risk that kind of technology. And now we've gone from 3D printing very intricate toys out of polymers to actually using that same capability to make something like this, the replica of a Shelby Cobra. Okay, so this is a prototype vehicle built last year in the US as a collaboration between the Department of Energy and companies and universities, and built from design to production in 12 weeks. And this is the US Secretary of Energy, Moniz, taking a spin in that prototype vehicle, so it really does work. You can do more than prototyping with additive manufacturing now. You can actually have companies that can turn a profit by customizing that 3D printed car for you on demand. Okay, so this sounds impressive, and it sounds rapid when you see it all on the same slide, but it took my entire lifetime to get from here to there. So why is that road of advanced manufacturing innovation so bumpy, so long? We can think about this in terms of a graph. I'm an engineer, I like to graph things. On the vertical axis, we'll make this dollars. And this could be profit and loss. This could be investment. And on the horizontal axis, we'll make this the production scale. So here we're talking about the very initial idea. This is the basic research and development where we generally fund this through governments and universities, to the far end where we're able to actually make a product at profit and sell it to the customer, the consumer, the defense market, what have you. And not just with one big factory, but increasingly with a series of micro factories that are nearer the customer. Okay, so that's the range of space. But in between the idea and the profitable product is this. Right? This valley of death. This is where most advanced manufacturing technologies and companies die, right in the middle. Because this is where the profits are very low. You are investing, but you're not actually seeing the return on investment. So why does this gap exist for advanced manufacturing, and what can we do about it? This is the challenge. So the gap exists for a few reasons. One of these reasons is that in this middle, this is where we're de-risking the technology. 3D printing for cars didn't work right away. It was only working for a very narrow set of materials, and it certainly wasn't working at yield or cost that would ever turn a profit. Manufacturing is capital expenditure intensive. We're not making apps. We're building things, real things that require real machinery and real training of the individuals who are making them. So that CapEx intensive operation, that requires investment. And there's low or long return on investment for banks, for venture capitalists, for governments, and so it's hard to finance this middle gap. Third, you need a workforce that can actually do this new kind of manufacturing. And that means retraining your existing workforce, training your new kinds of students to do this, and that doesn't happen overnight as well. So for all these reasons, there's a big gap. And then you can think about the role of the government. If regulation or tax policy is uncertain, not that it's not there, but that it's uncertain or it's changing rapidly, this prohibits investment further by companies. So we don't have vertically integrated companies that take us across this gap anymore for the most part. So how do we bridge the gap? And so increasingly, the way that we're bridging the gap in advanced manufacturing technology is through public-private partnerships. And this is where governments, and this could be federal government, state government, city government, are working with the companies directly, small, medium, and large, and with academia, from community and technical colleges to universities, to work together. and side by side with economic development organizations to fund and make the sustainable manufacturing innovation ecosystem. So it has a local flavor to it, a regional strength and investment flavor to it, where every stakeholder has some skin in the game. Every stakeholder is putting real money, real time in to build this manufacturing innovation ecosystem. And so we'll take a look at a couple of examples of these at the national level, but there's actually levels that are below that and also successful. So here's a map of Germany. Germany has a very strong and well-earned reputation for being very industry responsive, very manufacturing forward, and those manufacturing careers are perceived to be of high value to the citizens of the country. The Fraunhofer Institutes, there's 60 of these in Germany. There's billions of dollars of investment by the German government in these institutes, are a big reason for the success. Not only because they have the local governments paying into the system, and not only because a third of the money for these institutes has to come from industry or privately funded projects, but because there's also a focus on the workforce training and a strong model of apprenticeships and internships within companies so that researchers, students are paid to learn as part of their training. And this has become so well received that the Fraunhofers aren't even contained within Germany anymore. You may have one in your country. In fact, they exist in North and South America, near where I live, near where we are right now, in countries like Japan. Now, if we look at Japan as a particular model, they have a different approach, a more concentrated approach in terms of the manufacturing technologies they're developing, but still it's a public-private partnership. They're between the AIST, a federal agency, and companies like Kawada, and focusing on manufacturing technologies that are of interest to the consumers and also play to the technical strengths of the country. This is a strength of manufacturing in Japan and has been a focus of investment, along with 3D printing, where the government and these private companies are working hand in hand. In the UK, there's a different model. This is called the Catapult Innovation Centres, and 7 of these in the UK are actually focused on manufacturing. Each of these is partnered with industry ranging from Boeing to automobile companies, very focused on workforce training and growing small companies and making them healthy. In fact, one of the most recent stories that came out of these was that this program of the Catapult Centers helped produce the materials for sample delivery for mission to Mars. So a lot of really interesting activities coming out, and this type of public-private partnership, as we make this EU transition, will be very important to keep an eye on for the production economy within the UK. And as we've already talked about in China, you actually see a lot of this activity happening, but a transition going on here as well. Because in China, we don't want to just make things that are invented elsewhere. In China, we also want to invent and innovate on the products, the processes, the materials, and have them made here or elsewhere. So that's a transition, and the China government has just announced 15 manufacturing innovation centers that will be launched in the coming years to just that end. Workforce training in Africa in the manufacturing center targeted towards women. Made in India campaigns to focus on production-conscious consumers in that part of the world, so trends all over. But in the US, when we tend to rely on market competition rather than industrial policy and planning, we also have a network for manufacturing innovation. And in fact, President Obama in 2013 announced the National Network for Manufacturing Innovation. In the US, this is anchored by 15 different institutes, each on a different topic. The first one was called America Makes, and that was on 3D printing or additive manufacturing. But now we have a whole range, including digital manufacturing in the middle of the country, and one that is so new in smart manufacturing for clean tech that it was announced last week and it doesn't even have its official logo yet. And this is a subset of the 15. 5 more are under competition right now in topics ranging from biopharma to robotics manufacturing. So each of these, although on a different topic, is intended to work together so that the 3D printed materials in Ohio support the composites manufacturing in Tennessee, so that the integrated photonics that are made in Massachusetts support the flexible electronics that are manufactured in California. So there's this synergy, and then there's also this focus on workforce training so that the skills are adaptable and can move from advanced manufacturing industry to industry. with everyone having skin in the game. So I'll close with just a couple in which MIT is heavily involved. One of these is called Advanced Institute for Manufacturing of Integrated Photonics, or AIM Photonics. Here's an image of what those are. So it looks like a semiconductor wafer, but in fact the devices on it use light, use photonics to pass information and represent a new class of lasers, communication devices, kinds of devices we'll use for driverless cars. And so the way that we get there through these institutes includes startup companies, such as the one that's represented by this individual here, people who've worked in labs for years to drive the technology and then teach it at the university level shown here, but also a real focus on who the manufacturers of the future are going to be. Who's going to do these wafer runs within the companies? Who's going to assemble and test the devices before they go out the door to the consumer? Who's going to figure out how they actually work in production lines to speed productivity of other kinds of manufacturing? That's the focus of these institutes, the technology and the workforce training together. And then as a reminder on the next one that MIT is heavily involved in, for advanced fibers and textiles, when we learn how to manufacture objects or materials in a new way, we can open up whole new product segments that we haven't even thought of yet. And that's part of the new production paradigm. So what I'm showing you here, these funny objects that are about the size of your thumb, are called preforms. They're made out of polymers, but other materials. But when we draw them down to fibers that are about the diameter of your hair, these also can become photonic devices where they can sense and communicate and pass information. But it's in the form of a fiber, which we can then make in the form of a textile. And not just a textile that you would wear, but a textile that you would use for highly complex structures. This is the basis of one of the other institutes in the US that will officially launch in October, Advanced Functional Fabrics of America, or AFOA, as you see here. And again, the focus is on the workforce training. This sounds great. Who's going to make it? Where is it going to be made? And so the focus on the workforce training and the skills gap is important to every country, but also in the US, as you can see from this poster. Some countries like Germany have made great strides in manufacturing being an attractive career. Being part of production is attractive. But not all countries. In the US, it is still a struggle, and it's really a call for a new generation of a Rosie the Riveter, right? And that Rosie is going to need to have skills in digital design and manufacturing, not only hands-on manufacturing, because what we're making is made in a different way. So because of that, it leads to one final challenge in the workforce training and how companies and governments and universities start to communicate with each other, and I call that production integrity. So this represents intellectual property, passing digital data from machine to machine and country to country. This represents how we actually adapt to changes in production when data standards are also adapted. So how we address this final phase of this current industrial revolution, this production integrity with a skilled workforce that's adaptable so that we can invent it here and make it here, that's the challenge of the next production paradigm. Thank you.